Today's topic is equipotential surface. Now, the word equipotential, it is made up of two words. Equi matlab equal, and potential, as it is clear, it is potential. So therefore, the surface which has equal potential everywhere is called equipotential surface. So definition is like this one. Two types of definitions are there. The surface at which potential is same everywhere. Same everywhere is called equipotential surface. Second definition, the surface at which the potential difference between any 2 points is 0 is called equipotential surface. Now suppose this is the surface and I consider 2 points A and B. Now if the potential at point A and potential at point B, if these are same, then this is surface, and just like you can say that there are so many points on the surface, if between any two points on this surface potential is same, then this is equipotential surface. Or otherwise we can say that the potential difference between any 2 points, if the potential difference, this is the difference of potential difference, if it is 0, then the surface is said to be equipotential surface. You can see that as VA is equal to VB, so therefore their difference must be equal to 0. So this is the second definition what I have written that here. Out of these two definitions, any one you can write. The surface at which the potential difference between any 2 points is 0, then that is equipotential surface. या तो कह सकते हो the surface at which potential is same at everywhere, मतलब at each and every point on the surface is called a equipotential surface. Is it clear? समझ लग गई? तो for example you can see that if I am having this point charge, now this is a positive charge, now I can take this point as the center and I can draw the circle. Now I can also draw this circle from here. You can see that this one. Now this is the center. Now this is the center. At this center there is a charge Q. As there is a charge Q, you can see that Now at the center there is a charge Q. Now you can see that the expression for potential is equal to 1 upon 4 pi epsilon naught Q upon R. Now you can see that as this center where the charge is placed, the distance of the circumference of the circle in a two-dimensional and sphere in three-dimensional, the radius is same, because you can see that in this expression here you can see that except the R, 1.4 pi epsilon naught constant, Q is constant, so therefore V, it depends upon R only. V is inversely proportional to R, but in sphere R is also constant. As R becomes constant, so therefore from this expression you can see that V will become equal to constant. So that is why if we are having a point charge here and we draw a spherical shell around it, then this is an example of equipotential surface. Clear? Now how many spheres I can draw with the Q as a center? How many spheres? How many spheres I can draw? They are infinite. कितने ड्रा कर सकता मैं? Infinite ड्रा कर सकता ना? You can see. Now if I take this as a center here, I can draw so many spheres. Actually it appears to be a circle, but it is actually a sphere in 3D. Now I can make it like this one and I can change the color. Now therefore I can draw another sphere like this one, and if I change the color and I decrease the radius, I can draw another sphere. Therefore you can see that here I am having different spheres with the different radii. This is radii 1, then for the second one this is the radii 2, and for the third one this is the radii 3, and for the fourth one this is the radii 4. Therefore you can see that I have different spheres. Such type of spheres I can draw infinite in number. But what is the difference between these two spheres? The blue sphere has one potential, but its value is different from what is the potential for the red sphere, and similarly the value of the potential is different for the green sphere, and the value of potential is different for the yellow sphere. But the yellow sphere is equipotential surface in itself, green sphere is equipotential surface in itself. Now what do you think if I write down V and I write down V and I write down V and I write down V? What do you think? These V will be same. V blue means potential at the what? Blue sphere, and red means potential at the red sphere, green means for the green and yellow means for the yellow. What do you think? Are these equal? Which one will be greater? Very good. Yellow will be greatest. After that will come green, and after that will come red, and after that will come blue. Therefore you can see this, that as r is smallest in case of yellow, here the radius is smallest in the case of yellow. Potential, you can see this formula, V is inversely, I have written here, you can see here, V is inversely proportional to R. Smaller will be the R, V will be more. So therefore V, yellow will be greatest, it will be more than green, green will be greater than red, and red will be greater than blue, and blue will be smallest because the radius of the blue is largest. समझ लग रही है ना? Clear? So in this way, these are the examples. This is an example of the equipotential surface. Clear? Now we will discuss the properties of the equipotential surface. Now you can see that the surface on which the electric potential at every point, ये देखो definition दोबारा, at every point is same, is called equipotential surface. Now a line perpendicular to the surface gives the direction of electric field intensity. Now this is the diagram of potential due to a point charge. Now we have discussed in detail, these are the equipotential surface because of the point charge, and this diagram, this is the equipotential surface for the uniform electric field. Clear? And next one is, here is the equipotential surface. You can see that these are spherical nature for the dipole. This diagram, ये diagram थोड़ी incomplete है. Clear? Next one is, this one is due to two similar charges, the equipotential surface. The dark lines, these dark lines are equipotential surfaces, and dotted lines are what? Dotted lines are electric field intensities. Now the properties, a diagram जरूर कर लेना. The properties कड़ियाँ हैं क्या? The first property is this one. No work is done in moving the charge on the equipotential surface. Work done on equipotential surface is 0. Now we know the definition of potential difference. Potential difference is equal to work done in moving the charge from one point to another divided by the magnitude of charge. But for equipotential surface, potential difference is equal to 0. Therefore work done per unit charge will be equal to 0. It means work is equal to 0. So therefore on equipotential surface, the work done in moving the charge is always 0. Sometime a question is asked. For example, here I will take this example. Suppose this one is, and on this we are having 2 points A, and this is B, and sometimes the question is asked, the charge is moved, any charge say Q naught is moved from A to B, and here this is the center of the sphere, a circle where the charge Q is placed. Now the charge is moved from A to B, then what is the work done? The answer will be 0. Clear? And if they say that the charge is moved from A to B like this one, not along the surface but directly from A to B, then will there be any work done? Will there be any work done? The answer is again no work done because we know that electrostatic field we know that electrostatic field, this is a conservative field. Being a conservative field, it does not depend upon path, it depends upon initial and final positions. As initial and final positions are same, so therefore it does not matter whether we come across the curved surface or we go straight from A to B. It does not matter what is the path. Initial and final points are same. So therefore the work done in any path, it will be always equal to 0. So therefore until the points are on the equipotential surface, the work done will always be 0. Is it clear? Now next one is, we know, I will take the previous knowledge, what we know, the work done on equipotential surface is equal to 0. I can write down mathematically as work done is equal to 0. It implies, what is the work done? Work done is equal to force dot displacement, then F dot dl must be equal to 0. For example, you can say that if this is the surface and I moved some charge along the surface through a very small displacement dl, clear, by applying some force. So therefore F dot dl must be equal to 0, and it implies, but F is equal to what? F is equal to E, because what is there? E is equal to F upon Q. So F is equal to E multiplied by Q. E dot dl must be equal to 0, and it means Q, we will take it out. E dot dl must be equal to 0. It means Q E dl cos theta must be equal to 0. And from this relation you can see that Q is not equal to 0 because we are having a charge. E is not equal to 0 because some source charge must be present there. As we have moved the charge, dl is not equal to 0. So therefore only one condition is left. Then only what is left? Cos theta must be equal to 0. That is why this relation is equal to 0. And as cos theta is equal to 0, it means theta must be equal to 90 degree. So what is the theta? Theta is the angle between E and dl. So this proves that, therefore this proves that E must be perpendicular to the surface. E must be perpendicular to the surface. That is why their dot product is always equal to 0. And this proves the condition, that is the second what is, we can say that property of the equipotential surface. What is that? E means electric field. E is always perpendicular to the equipotential surface. This is the second property of the equipotential surface. You can see that this one, no work is done, we have done this one, clear. And what is there? We have proved this one. Now property is here, this one. This property I have discussed. Electric lines of force are always perpendicular to the equipotential surface. What does it mean? And I have given the proof. Clear? And from this one you can see that it has also proved that E dot dl is equal to W upon Q, VAB minus V1, line integral of electric field is equal to this one. For equipotential surface, these are equal to 0. Clear? वही चीज है ना? And therefore, here he said that E dot dl cos theta must be equal to 0. E will be never 0. Dl is never 0. Clear? So therefore, cos theta must be equal to 0. That is theta is equal to 90 degree. Is it clear? Then next property is this one. Just like electric lines of forces, two equipotential surfaces can never intersect each other. For example, I have in this point, and this is the one equipotential surface, and suppose its potential is for 4 volt, and this is another point, and this is having its own equipotential surface. Now suppose its potential is say 6 volt. Therefore you can see at this point of intersection we are having two values of potential, 4 volt as well as 6 volt. So as two values of potential at a point are not possible, so therefore these can't intersect. These can't intersect. So that is why two equipotential surfaces can never intersect each other. Is it clear? सुन रहे हो? हेलो? क्लियर हो गया?